Hello everyone, today we will see the one-way slab design. Is the question of one-way slab design. So let's see. Design a simple supported RC one-way slab for a roof of a hall 3.5 meter into 8 meter inside diameter with 250 millimeter wall around. Assume the live load 4 kN per meter square and floor finishing 1 kN per meter square, and concrete strength FMC is 20 megapascal and steel yielding stress of 415 MPa. So let's start to solve the one slab. At first we have to select the type of slab. This is the beam supported slab. The ratio of span, long span divided by short span. Here is the long span 8 meter and here is the short span 3.5 meter, and ratio is 2.2, which is greater than 2. So if we found the ratio of long span divided by short span is greater than 2, so we can say that this is the one slab. Okay, so we will confirm that is the one slab. So second step, we have to find out the thickness. There are numerous various formula have for finding the thickness or depth of the slab. But we will use this formula, which is short span divided by 25. So our span is short span 3.5 and divided by 25 and get the 140 millimeter, and total depth will be there plus clear cover plus which bar we have used divided by 2. So 140 plus 15 plus 10 divided by 2, which is 160 millimeter. This is our depth of the slab. Okay, let's see the step of 3 is the left calculation. The self weight of slab, which we know we find the self weight of slab is unit weight of concrete and multiply the thickness of the slab. So unit weight of concrete is 25 kN per cubic meter and thickness of slab is 160, which is 0.160 meter. Okay, so the self weight of slab is 4 kN per meter square. And the second is floor finishing 1 kN per meter square, and the total we will find the dead load self weight of slab plus floor finishing, which is 4 plus 1 is 5 kN per meter square, and live load 4 kN per meter square. And the value is given from or found from ACA 318 or ASC 701 is CE 705 or 01, 05 or 010, 07, which is very nearly published. Okay, or PNBC. So our design load will be 1.6 dead load plus 1.2 dead load plus 1.6 live load. So 1.2 into 5 into 1.6 into 4, which is 12.4 kN per meter square, which is this is our design. So effective span of the length span, we will use the two formula for getting the value, and we will take the less value for the getting the effective span length. The first formula is span plus width of the wall. We know the width of the wall is 250, and the second one is span plus depth of slab. Depth of slab is 140 millimeter, which is 0.14 meter, and we will found 3.75 meter and 3.75 meter and 3.6 meter. So we will take the less below 3.6 meter. Okay, let's see the next step. The next step is very important for getting the moment of the slab. So moment is W square by 8. So there we can use the coefficient method. If you use the coefficient method, then the value will be changed. So the coefficient we have used WL square by 8 for our coefficient 1 by 6. So if you want to use the another coefficient which is 1 by 8, or if you will 1 by 12 or 1 by 10, so this will be changed, but it will be very minor change. And the same way we will calculate the shear value, which is WL by 2. So we'll get that 22 into 57 kilonewton per meter. And the next step 6 is calculate the steel ratio. There is a two method we have found, like there is a two type of formula for calculating the steel area. Here is the number one, and another one is here. So we will see the two method to calculation on the steel area. So this is the ACI 318. It is taken from there. So m equal to 5 rho b square Fy 1 minus 0.59 into rho Fy by Fnc, and putting this value and finding the value of rho, which is 0.00 or 22, and this is the greater than minimum value of rho. So our S will be 0.0022 and P will be 1 meter, which is 1000 millimeter, and depth is 160 millimeter, and we have found 152 millimeter square. This is the method 1, and we will see the another method to calculate the value of the steel. So another method is very commonly we have used, so which is compression block A equal to S Fy divided by 0.85 Fnc, and putting this value as into 415 divided 0.85 into 20 into 1000, and getting 0.024 into S, and finally you will see the another and putting this value for in the this formula, which is S equal to m divided by Fy into d minus a by 2, and equal to 20.54 into 10 to the power minus 6 and 415 into 160 minus 0.02 4 into S in divided by 2, and getting the value of S for steel area 316 millimeter square. This is our method 2. We will get the steel area 316 millimeter, and found the method 1 352 millimeter square, which is very closer value. So we will use this method or this method, but I will recommend this method because this is used in SA 318. Okay, so we will using 10 millibar. The area of 10 millibar is 78.5 millimeter square, and spacing will be B into S divided by S, which is 1000 into 78.5 divided by 4 from 352, which is 2 to 3 millimeter square, and we will use 2 to 0 millimeter, which is 8.8 center by center. So this is the result for main reinforcement bar, 8 millimeter main reinforcement bar at the rate of 220 or 8.8 center by center. But in the practical field we will not use 8.8. We will use 6 inches center by center for the staying at the safe zone as a structural engineer. But we will find this value 8.8 inches center by center by calculating. Okay, let's see, and we will revise the value for providing S equal to P into S divided by S, and get putting spacing B and S, and get the S value 375, and we will see the steel balance steel ratio or rho value, S equal to BD into 100, S equal to 375, B into 100, and D into 165 into 100, and which is 0.22% or 0.00 0.002, which is we have found already here the rho value 0.002, so we can see this is okay. So as a step we'll see the distribution bar. So we'll see the distribution bar as equal to 0.002 BT, which is given in SCI code. The formula is found from SCI code. So 0.0012 BT B equal to 1000 millimeter and T equal to 160 millimeter, which is found 192 millimeter square, and we'll use 8 milli distribution bar at the so area will be 8 milli distribution bar 50 millimeter square, and spacing will be as divided as b into as b divided by s. So as equal to 50 into 1000 divided by 192, and getting the spacing on 260 millimeter, which is 10 inches center by center, and this is the value of distribution 8 milli distribution bar at 260 millimeter center by center. But we will use practically 8 inches center by center distribution bar as taking the safe zone. So here is the reinforcement. This is the very important for detailing. So this is our 8 meter span, and this is our 3.4 meter span. So we will use the main reinforcement bar in the short division. This is very important. This is our main reinforcement. We will use the short division. This is our main reinforcement. We will use short division. So this is we have used in 10 millibar 10 main bar 10 millibar at the rate of 220 or 8.8 inches square center by center. The main reinforcement bar must be used in the shorter direction. On the other hand, we will use the distribution bar. Distribution bar will be longer direction. This is our distribution bar. We are using the longer direction or perpendicular to the main reinforcement bar. So our distribution bar 8 millimeter distribution bar at the rate of 260 or 10 inch center by center we have used here. So if we see this if we see this reinforcement on here, so we can see the cross section here given here. The distribution bar is, at first we will see the main reinforcement bar. Okay, so this is our main reinforcement bar. We have used here this way and this way. Okay, and this is the cross section of the slab, and we will see the distribution bar. Distribution bar is used this way. It is the perpendicular of the main reinforcement bar. That's why we will use this way. Okay, and another thing is another two type of only two river have used at the top of the joint or support. We have used at least two bar we have used at the top of the joint of beam or column support, because of there have many shears, and this reinforcement will resist shear and torsion. That's why we will use additionally to reinforcement. At least two bar we have used at the top of the joint. So this is that's all from me. If you have any question or comment here or mail me. Thank you.